Hello, good morning, good afternoon, greetings from San Francisco. This is Umesh Holegata. I'm the Chief Technology Officer at the New Sigma Analytics Lab. Today I also have Mr. Umesh Nayak, who is the CEO of New Sigma U Square Analytics Lab and also co-author of my book, Business Analytics Using R. We provide AI solutions, and also we mentor, guide, and conduct workshops on AI, machine learning, TensorFlow, deep learning, etc. with our New Sigma Analytics Lab. So today we are going to talk about one of the most important aspects in data science, that is, how do we execute these machine learning and deep learning projects? So what are the practical challenges that you have while executing these machine learning and AI projects? So we are going to look at both the theoretical aspects of the project execution, and as well as we are going to talk about an example of a project that we have executed based on our experience and what we have learned. So first things first, so this is the outline of today's talk. We talk about the machine learning and AI project, what is the framework, and how do we deploy. And then we take an example as a case, and then Mr. Umesh Nayak is going to explain the case in detail. Okay, and then finally we would like to take question and answer, and I encourage the audience to ask more questions so that it will be an interactive session. And if we cannot answer during this session, we would like to take all the questions and we'll respond through another session or by email in person. We are going to respond to all your questions. So kindly ask questions, and we would like to hear the feedback from you. So in general, this is the typical software project cycle. So I would like to take, because most of us are from software engineering background and we have executed several software projects in the past. So I would like to take a typical software project cycle, how it is executed, and then I would like to take the machine learning project life cycle, and then the framework, how it is executed, and how it is going to be different from the typical software project life cycle. So in typical software project lifecycle, you start with, you already have a fixed requirements that is derived from your marketing or business people, and then you have a hardware, software requirement, and then you try to align, business is very well aligned when they come up with the requirements and when they want to execute a project. And based on the requirements, very well understanding of the requirements, you go ahead and do the planning. You do the resources allocation, scheduling, and you plan for your development, testing, and deployment. And also, you come up with your risk analysis, risk planning. Then you start executing the project. You constantly do monitoring, you track, you go back and reassess the risks, and then you calibrate the project as and when required. So once you have completed the initial stage of development testing, then you go ahead with your deployment schedule or deployment planning by conducting the beta testing, and then finally it will be deployed in the field, and then you go back and look at how the project went, what are the challenges you faced through the feedback and closure. Okay. So this is the typical life cycle of software project. The important thing is there is a very well-defined requirements you have, and then what kind of tools that you have to use, what kind of hardware, what is your performance, all those things, what is the environment you will be working, all those things are very well defined and captured at the beginning of the project. However, let us look at how machine learning project is done, and what would be the typical framework, and what would be the cycle of the typical project life cycle of machine learning. Okay, so before this is the machine learning cycle, project life cycle. So here again, there's a project initiation, if you want to call. You will try to understand the business requirements, what business is trying to achieve through machine learning. Okay, so you try to align the business requirements with the business and try to understand what is that the business is expecting. Is it something predictive model, or is it something just a descriptive model? So you try to gather as much as information from the business and try to understand what exactly the business wants, so that you can go to the next level. So once you have an understanding of the business, then you have to go back and look at the data. The big difference here is, entire project depends on the data. So what kind of data that you have? Is this data available to you? Where is it available? How do you access the data? Yes, sorry about that. It went into mute for some reason. So the important part is the data. So you have to understand what kind of data that you have, what kind of quality of the data you have, and probably whether you are able to solve the business problem with the data that you have. That is the most important thing. So it may happen, business may be expecting something totally different, and the data you may not have to solve the specific problem the business is expecting. And it is very important that you communicate back to the business, saying, okay, this is the business requirement that you are expecting, this is what you are expecting, whereas the data that we have, we will not be able to provide the exact business requirements. So then what do we do? So, then you go back and figure it out. How do you get the data, or maybe when the data is available, you again go back and start the whole process. So once you have assumed that, business has given you the requirement, you also have the data. So once you have the data, then, you spend enormous amount of time to make sure the data is of quality where you can apply the data to build a specific model. So once you have the data, you go back and then you try to build a model. It could be a predictive model, it could be a descriptive model, it could be a prescriptive model, whether you would like to use supervised machine learning or unsupervised machine learning or semi-supervised machine learning. So these are some of the things that you should go back and try to build the model. And once you have the model, so then there is a science part of it. So most of us always wonder, what is the science to do with data science? Why do we call this as a data science project? So what are those things that are involved in data science? Okay, so I will explain more about it in the next slide, but quickly, once you have this model, then you got to go back and then understand whether the model is giving the proper output, right? What is the accuracy of this? How do we measure this model? What are the parameters that are influenced? Is there anything that you have to change the model or revalidate your model? So these are some of the things, the science part of your data that you have to do. It's more of conducting an experiment, which is very similar to your physics or chemistry or other experiment, which is very much similar. And then once you are satisfied with the model, so you will go and then deploy the model and then calibrate the model as and when required, and deploy it to the field and get the feedback from the users. And constantly you go back and then recheck, and you may have to calibrate whether the model is working as per your requirement. And you may also, over a period of time, you will get a different kind of the data. So then again, the model may not give accurate results with the new data which has never seen before. Then in that case, you have to relearn, the model has to relearn, and then you have to recalibrate, and then go through the whole process. So as I said, this is not just a one-time project where you build a model and then you deploy and then it will work forever. It is constantly, you have to revalidate the model and then calibrate the model, because everything depends on the kind of data that you have and the kind of data that you keep getting as and when your data is available. So this is the big difference between your software cycle and then your machine learning. So this is the typical framework I would recommend to follow, and this framework has been explained very well in my book. So I would request you to look at that for more details about the framework itself and all the steps that are involved in executing the project. So this is the typical machine learning framework. So before we proceed, I would like to take one small quiz from the audience to find out what is their experience. What is the experience executing, working with your business executives on machine learning projects. So I would like to understand from the audience whether, what business executives think when you talk to them. So do they think machine can solve a problem even without understanding the problem? Technology is very much evolved. The business understanding or understanding of the business problem is no longer required. Or do they think machine learning can do magic, so we don't have to worry about whatever we give to the machine will give something that will be usable. So I would like to understand what is your experience and what people in your organization think when it comes to the machine learning projects. Okay, so as and when I get the results, I am going to go and share with you. Right now, I will allow the audience to answer the questions, and then let us just move forward to the next slide. Here, as I said, the data is very, very important aspect of the machine learning project, right? So output totally depends on the kind of data that you have. If you have inaccurate data, then you end up in getting wrong predictions, and then you may end up, business may end up doing wrong decisions. Incomplete data, right? So one is inaccurate data and accuracy of the data. Incomplete data may not be complete. There may be missing values. It can be, human may have made some errors in entering the data. So that will result, if you don't fix all this data, then you will end up having an incomplete model and misunderstanding of the model itself. Probably your effort also can be wasted. So if you input junk, so you can expect output also junk. So it's very important to fix all these problems before you even build the model and look for your accuracy and try to understand how the model is behaving. So again, if you don't have a lot of data, if you have very small amount of data, and it may not be very useful. More the data you have, better your understanding of the model and better the model behavior. and data does not encompass all the business scenario, right? So as I said, business may be expecting 10 different things to solve. However, the data, you may not have all the information that is required to solve your problem. So it may happen that if business has given you 10 requirements, you may be able to solve only 4 or 5. Okay, so that is very important that people and business they understand this particular aspect of the data. So the data is the key for machine learning and AI project. So that is what I would like to emphasize here and highlight why data is important. And it is very important for the people who are working on the project to communicate to the business, so business understands the importance of data and why you are not able to solve or meet all the requirements that is given by your business. Okay. So another thing that I come across, people asking me a lot of questions about model. What is this model? Whenever we talk about this machine learning, model. Essentially, I call this as a box which has got some input and an output. And inside the box, basically, it is nothing but a function. It could be a polynomial function, it could be a probability function, it could be a Fourier transform, or it could be a set of functions. So basically, all this model is try to understand the data, and then it tries to fit appropriate function. It could be probability function, it could be a naive Bayes or a logarithmic function. So the output of this function, depending on one, the kind of data that you are inputting, and the function itself, how well your function is fitting your data, and that is what the output that you can expect. So essentially, if you just look at one example I have given, f of x is a squared plus b squared plus c squared. So a, b, c are your input points, and f of x is a function which is a squared plus b squared plus c squared. So that can be a model, right? So depending on what the problem that I'm trying to solve, so this itself can be one example of a model. Okay. Similarly, depending on depending on the problem, whether it is supervised or unsupervised, the model could be your naive Bayes, based on your Bayes theorem, naive Bayes classifier. It is based on Bayes theorem. So similarly, decision tree, right? Logistic regression depends on your logistic regression function, regression, linear regression, or polynomial. Okay. This is what the model is all about, and you can expect the input. You feed the input data, and then you can expect the output of the function, of a specific function or specific model that you are trying to use. Okay. Then another important question is the science. Where is science coming here? Why are we calling data science? Okay. So I gave a lot of thought about this particular question, and then I took the definition from dictionary. This is from Webster Dictionary. So the dictionary definition of science, it says the intellectual and practical activity encompassing the systematic study of structure and behavior through observation and experiment. Okay. So if you look at it, if you are conducting a physics or any science experiment, so you have a hypothesis, right? So based on the hypothesis, you conduct experiment. Okay. For example, H2SO4. So you have a hypothesis, your aim is to come up with this H2SO4, and then your experiment is you have to add equal amount of hydrogen and then oxygen and sulfur, and if you add proper proportion, so then you end up getting your H2SO4, right? then, once you have the result from your experiment, you analyze the results. And then, you measure, depending on, if you are conducting physics or biology. So you are going to measure, and then if required, you repeat the cycle. If you have noticed in your class of 60 in your 10th or 12th standard, while you are conducting the experiment, so probably all the 60 people have come up with slightly different measure or slightly different readings. Okay, sometimes these will develop into scientific theories. So that is how science has evolved, and that is how so many theories have evolved over a period of time. So now, how does this apply to your machine learning and AI? Why is it called data science? So now, if you look at it, so everything is depending on the data. Okay. So now we do not know what kind of data that you have and how many features or parameters that you have in the data, how all these parameters are influencing your results. Okay, so that is all your experiment. Basically, you have a hypothesis, that is your business requirement, I assume, that is a predictive analysis you are doing. So now you are conducting an experiment. Now there are so many number of parameters or features that are in the data. Now you do not know which one is actually influencing, which one may not be influencing. So each time when you conduct an experiment, that is building your model, and you sit and analyze the results and then try to improve your outcome, right? So that is what is repeating the cycle. And then, during the process, you may end up coming up with a new algorithm itself, new model itself you may build. So that is the reason, we call this as data and then, data science. So it's very important for people to understand machine learning is not magic. Machine learning is not just like another software project. So there is a lot of science goes behind it. And if you don't understand the science part of it, you may end up getting wrong predictions and wrong results. And you may have heard a lot of stories, how AI project has been not doing well. And I covered extensively in a couple of sessions back. And recently, one of the news is Amazon has scrapped one of their AI projects. So you may go up and then look at the details by Googling. So it is very important, what kind of resources that you have, and what kind of people are working on the project, and how much of science, significance of science. Why is the PhDs are required everywhere? So people have to understand what PhDs actually can do or cannot do. So this is what the data science is all about. The science part of the data is all about. To achieve your goal, you need tools and techniques. The data, for example, to understand the data composition and data completeness, you can use some of the data visualization tools. To do the data cleaning, there are data cleaning utilities, including your regular expressions. You can use some of those techniques. To do the data scaling, you can use data scaling normalization techniques. Feature selection, there are utilities and there are algorithms to do that. For example, principal component analysis. You can use some of these techniques, and tools are provided by different libraries. So similarly, model selection, you can use appropriate, supervised or unsupervised, and depending on the kind of environment you are using, kind of libraries that you are using, you can select those things. And then finally, you have to tune the model parameters, and you can use various validation and testing, matrix and graphing utilities, F-measure or ROC curve, whatever, depending on the problem that you are solving. Finally, you go ahead and deploy the model, and then you do the calibration of the model. So when it comes to deployment, you have to deploy from the perspective of the users. End users is always very important. You keep that in mind, and make sure that all your machine learning model is deployed from the user perspective. And also, availability is, always important. What kind of environment you are running, and then, make sure that model is always running, whether it is cloud or it is in your private environment. So you have to make sure that, availability is an important aspect. And, deploy with clear instructions so the models are not misused. So when you expect the user to use the model, there is some input data that you are expecting from the user. So you have to give a clear instructions, what kind of data, whether it is a numerical data, whether it is a text data, whether you have to categorize the data, or whatever the data that you are expecting the user to input, and that has to be given clear instructions so that the users understands and then provide proper input so that they can expect proper output. Okay. Of course, it's always important you facilitate your feedback on how the model is behaving, and what is the user experience, what could be made to improve. So, this is kind of standard getting feedback on any project, for that example, So it's very important that you facilitate a feedback mechanism so that you get constant feedback so that you can improve the model regularly. Okay. So with this is the typical theoretical aspects of the framework. So we start with understanding the business requirement. So then we try to understand the data. So once we understand the data, then we try to build the model, and then there is a science part, and finally we try to deploy the model once we are satisfied with the output. So this is a typical machine learning framework. Now Mr. Umesh Nayak is going to explain one of the practical aspects based on our wide experience in executing several machine learning projects. So he is going to explain what are the challenges that practically we faced while executing the project. Umesh, over to you.
Thanks, Umesh, and good morning, everybody. And good morning and good afternoon, depending upon where you are from. And basically, as we have executed many projects over a period of time, and we have seen typical challenges. One of the important challenges which I am going to talk in detail is business requirement related challenges. So either businesses don't have sufficient time to provide the requirement clearly to the technical people, or the technical people do not understand the requirement clearly, either because of the lack of domain knowledge or because of lack of they are asking effective question to the business people. So data challenges, the problems may be plenty to be solved, and so the management of the organization may be excited to solve a lot of problems, because people nowadays feel that every problem can be solved by the machines, but so it is not so. So that is where the data, we require appropriate data to solve appropriate business problems. If we don't have sufficient data or relevant data, we may not be able to solve a particular business problem in hand. And that is what we see in the practical life when we get the projects from our clients. Model and output. Okay, so this is again, okay, so which particular algorithm to be used to create the model, that also depends upon data and whether we have labels for the data, and what kind of problem we are trying to solve, and what is the expected output. Based on that, we have to make appropriate selection of the model. and then so we have to also deploy it appropriately, and deployment itself is a challenge. Most of the time, but compared to the earlier ones, okay, deployment is a relatively easier one, and most of the technical people are good at deploying as we see. Resources, okay, there is again a confusion as to what kind of resources we want. Okay, do we require always data scientists, or is it enough for us to have only data engineers? These kind of questions rise, and we have seen multiple failures on account of inappropriate resourcing of any particular project. So I will explain each of these in detail. As I mentioned, we have executed umpteen number of projects, and both software and both artificial intelligence and machine learning projects we have executed. One of the problems when it comes to, okay, particularly it is more prevalent as we see, business requirements are not understood. Okay, there are various reasons for that. One of the reasons what I see is, technical people. I am also one of them, possibly. So technical people jump into solving the problems without even clearly understanding the business requirement. Okay. So business people sometimes give an overview, and then the technical people think that, okay, they have understood, but maybe there was a lack of clarity in what business explained, and subsequently what happens is we have seen business people are not available because of their busy schedule fighting with the customer issues. They are not available, and then, okay, so the requirements are not understood, and technical person continue in the belief that whatever they have understood is right. And we have seen at many cases, okay, in many of the projects, what the many other peoples have executed, we have seen that the business requirement was not understood properly, and subsequently business has felt that they wasted substantial time. So for that, resources, whether they are the data scientists who are involved or the data engineers they are involved, they have to ask appropriate questions. One, to understand the problem statement very clearly without any ambiguity. Second, to understand the data availability, what kind of data is available. Okay, so where is it available? Okay, so to what extent it can be made available to the people who are involved in solving this problem. Because of the confidentiality or the HIPAA requirement, sometimes the organization may not be inclined to give sufficient amount of data or appropriate data to the data scientists or data engineers, in which case possibly the engineers or the data scientists cannot help. What is the kind of infrastructure required? Okay, because nowadays we have huge amounts of data with the various organizations. That means to create the model, okay, to run the training itself, we require substantial infrastructure. Of course, over a period of time, that pain has reduced substantially. So status updates, okay, business requirements are not understood in the zeal, in the enthusiasm. Okay, technical people go ahead and try solving the problem. Okay, but business is not available to clarify. They think whatever they have understood is right. So, and many places we have seen that there are no weekly discussions as to the progress of the project, no weekly updates made to the business people. Okay, and so one of the very effective tool always is for a data engineer or a data scientist is to use demos of the work done so far to the business people, so that business is very clear where the data scientist or data engineer is leading them into, and then correct the course where required. And this is very, very important, but we see significantly this is missing in many organizations. And we have seen that the people have worked on the project for 4 months or 6 months, and none of the models have come out, okay, primarily because business requirements were not understood, and hence they are not met. So, and then what happens is the months are wasted, efforts are wasted, and the project is back to square one where from it started. So it is a totally waste of effort. So it is very essential that so the business requirement is understood very clearly, business is involved in the process, and problem statement is written down and signed off by the business people. And periodically, so the is made to the business people so that they can vet it and say that yes, you are on right track, or no, this is not what we wanted. And we have heard in many places after a few months, oh, business says this is not what we wanted. So data understanding. So as Umesh mentioned earlier, so understanding of data is very, very important. We can't jump directly because we have huge data at our disposal. The data may be half-baked, half-complete. Okay, data may have inaccuracies. So, and whatever data available and what the project requirement is, that is basically business requirement is, do not tally. The data doesn't correspond to the problem which is required to be solved, and then unnecessarily we will be wasting time. So, the feature selection, okay, so it's very important, and so one of the things the expert should normally check as to which are all the features which are very important, because pure technical things like PCA, okay, or some other mechanisms can sometimes, okay, remove a important feature which business understands or the business analyst understands. So we have to ensure that feature selection is done appropriately. Expert advice is also taken where necessary to understand the importance of the features, and then go ahead with our umpteen number of feature selection methods available to us, okay, and then check what kind of features have come into the bucket, whatever has been advised by the experts have come into that or not, okay, and then proceed cautiously. So not understanding the features is another problem. We can't simply jump into creating a model. We have to understand what each feature stands for. For example, feature 1 comes from, say, sensor number 22, and feature 10 comes from, say, sensor number 45. So we need to understand, hey, what is this sensor is pumping in? Is it heat-related data? Is it pressure-related data? What is it? Because that way we will be able to correlate the impact of that on the output of the model. So many times what happens, this is a problem, a universal problem, okay, the data comes from various sources, and in the process lot of garbage gets in or duplicates get in. So we should know the source of the data and ensure that our data is good enough to do a appropriate analysis. Otherwise, so the garbage in and garbage out, if we have a lot of junk data, then we can only expect a junk model if we have not taken sufficient care in understanding the data and cleaning the data before proceeding ahead. And we have seen this as the second contributing factor for the problems in effectively executing the projects. We have seen many people have jumped into model building activity without even understanding the data, which is not a good thing to do. So, and so there are different kinds of magnitudes of different features. We have to understand most of the time the scaling or normalization of data is required. Otherwise, technically one of the features will be overweighed in the model being created. So we have to understand that. So feature understanding is very, very important. And many times, okay, people do not understand or distinguish between where supervised models have to be applied, where unsupervised models need to be applied. So, and the composition of the classes, categories, etc. So we need to be clear on the fundamental concepts of data science, okay, and appropriately apply the projects. And sometimes, okay, where only typically supervised model works, okay, but we don't have a labeled data, we may have to look for ways to get labeled data, okay, and then proceed further. So but many times we may be able to use unsupervised machine learning aspects. But you should know that unsupervised machine learning aspects are still evolving compared to the supervised ones. Supervised ones are more evolved, and so hence can be executed with more confidence. Okay? So the just coding without science, that is what in the enthusiasm so most of the technical people do, and that is not a good thing. So we should understand the data, we should first understand the requirement, we should understand the data next, and ensure cleaning up of the data, and then only so after getting appropriate data, go to the next activity, that is model building. Here I have a quiz. Okay, so people can take up this quiz. So basically, in your working experience, AI project is it a science? Is it engineering? Is it magic? Is it hype similar to the .com one? So yeah, this is just to tinker your brains. Okay, you can start voting now. Okay, so going to the next one, model selection and validation. This is very, very important. So most of the time, so the people try out with the arbitrary values. Okay, of course, sometimes in the case of a small data or a small model building activity, it may work. But so we need to apply scientific basis for our model selection and validation. That is very, very important. There are multiple number of model selection methods available. Okay, we have to understand them, understand the context in which we have to apply them, whether they are appropriate, and then apply them. But many times we see the people start with some arbitrary values given to the model algorithms, and then try out, and many times that may not work. So we have to always look at the algorithms, the background of those, context in which they were developed, the limitations of them, and how we can so get to the nearest values for the hyperparameters or parameters required for those algorithms scientifically. So many times the values are misunderstood, hyperparameter values are misunderstood, what they mean, and overfitting is not considered. Overfitting is one of the problems. I have seen the data has got 99% passes and 1% failures, and obviously when you train, the model gives you 99% accuracy because that is what data is. But then so the people are very happy at saying that, oh, I got 99% plus accuracy, but that is so because model has turned out whatever it is as it is, and sometimes overfitting can lead to the value, okay, that is accuracy being very high, whereas when you take the test values further or new values to be given to the model, they fail miserably. That means model has not generalized, model has overfitted on the training values, so which is not good. So we need to ensure that the model is appropriately selected. Okay, whether we have to use random forest, whether we have to use decision tree, whether we have to use regressors, or so like for example Adaboost regressor, etc. So that decision we have to consciously make in the context of the requirement and in the context of the data. So, and another thing, I see this is one of the problems which is not good from the data scientist perspective. Even though an organization has got say X number of data scientists, one data scientist do not discuss with the other data scientists, thinking that, oh, they may lose their proprietary thing. There is nothing proprietary in this. If we collaborate with each other, so everyone gains in the process, and that is what wherever we are involved, we always facilitate that, so that the so there is good communication between data scientists because some of them can get stuck somewhere, and then the one suggestion can move them in the right direction. Otherwise, they may be moving in the wrong direction. So it is very important that people, data scientists, discuss with each other and collaborate with each other so that everybody's problem can be solved relatively easily. Appropriate algorithm has to be selected. This is very important, as I mentioned. Okay, just because the algorithm is available and just because it is applicable to the, say, for example, one of the supervised methods, we can't simply use it. We have to look at the context of how much data we have, how much labeled data we have, okay, how much failure instances we have got. In the case of fail-pass situation, is our data balanced? Okay, so in case of deep learning aspects, we should also look at, okay, hey, are the images akin of the same size, or the aspect ratio is same, or so whether some images are less lit, whereas some images are more lit. So is it of the same channel, that is so RGB or so black and white? So we have to look at and select appropriate algorithm, okay, and scoring measures. Okay, so one of the typical scoring measures people use is classification report or the confusion matrix. So you have various measures available related to various algorithms. So you have to use the appropriate scoring measures, and the beautiful ones and more exploratory ones are usually graphical ones. And Matplotlib has got a lot of features which you can use. Okay, and confusion matrix is of course the simple one in the context of the supervised learning. So yeah, so most of the time we go across or we listen, okay, in the project execution field, buzzwords. Oh, I am going to use random forest. I am using network graphing, I am using the probabilistic model, etc. But so many times, so people wrongly use them, as we have seen. Okay, so without understanding the problem and the appropriateness of these to the problem. So basically, what I mean to say is, as per our experience, okay, so we have seen that wrong algorithms are used or wrong methods are used, okay, and hence we had so the observed that the issues have come up, okay, and that is where so we are always focused on business requirement, ensuring the data is clear, complete, and so without so any wrong values as far as possible, we do that, and then only so we go to the model selection. We think a lot on what kind of model we have to apply, what is the relevant algorithm, and so how do we understand what are the hyperparameter values which we need to start with, so in the context of that particular algorithm, and then so how do we increment them or decrement them to ensure that we reach the optimum solution as early as possible. Otherwise, as you know, we may be groping in the dark. So the next important thing is deployment. So, and we have seen many times, okay, so sometimes the organization want to deploy only a small environment, but sometimes we have seen that systems are not scaled up to accept huge data. In the normal so scenario, the data may be of X size, but in a particular scenario, it may be of size higher than that, and we have seen because the system was not scaled up to accept huge data, it fails. So it is very important whether you deploy it in-house or deploy on this cloud. You should ensure that, okay, so the infrastructure including memory, CPUs, storage is scaled up to all the cases so which are going to come. So system resources low leading to crash of the system, so we have to be very careful about this. So and so most of the time, okay, so my suggestion is I have seen people using trying to load the huge data into the memory or something, but always a batching is a good practice to do. so wherever possible. And the instruction not clear to the user, Umesh already talked about this. Okay, instructions are very important. User doesn't know that he has to give a .png in the particular context for deep learning, but he gives .jpg and then he looks at, oh, what went wrong. So because it was not clear that images only in .png in that particular context, okay, is used. So feedback not obtained. Okay, system may not be working up to the expectation, but so many times I have seen people feeling no, system is okay, system is working, and so in that the feedback is not obtained, which is not a good sign. We have to keep going back to users and look at and understand whether we are living up to their expectations. And then, so one of the very important things, okay, changes, things will change. Change is the only context in today's world. We have seen that outputs are not calibrated with changing context. Still adverse impacts felt strongly. So basically the changes keep happening, and when the changes happen, you have to ensure that the outputs are calibrated frequently, and then ensure that, okay, so for the new scenarios, your model is still relevant. If it is not, so then you may have to retrain your model, rebuild your model, and then validate your model, and then deploy the new model after calibrating the thing. So the project problems we have seen. Some of these. So we have seen so far what are the typical issues happen in the project execution life cycle. Like the business requirement not understood, data not understood properly, data not cleaned up properly, and then model selection not done properly, algorithm not selected properly, etc. So there are also project-related problems. Okay, project managers need to be involved completely. We have seen project managers just asking status reports, but my view is that so the project managers need to be involved deeply into the project so that they understand, okay, what is this requirement, and so how the project is progressing. Otherwise, at a later date, so they may be at distress or maybe deep stress, because the project has not gone the way it was supposed to go. Project requirement not understood properly. Project steps not envisaged properly. Yeah, we have umpteen number of steps. For example, you leave out the data understanding and data analysis and data cleaning steps. Okay, so your project can entirely fail. So you have to envisage the steps and sub-steps of the project properly, and that is where we require good project managers to execute this kind of project. Project tracking not done systematically, and so these lead sometimes to surprises. We have seen in some of our customer place 4 months, 6 months down the line, so the people say, hey, the project has never moved. So to the extent it was supposed to move, or it is where it was 3 months back. So project documentation not done properly. Okay, so this is one of the problems when somebody leaves, a data scientist leaves and joins some other organization. Okay, he would have done some work, but there is absolutely no documentation, and so that is where it becomes difficult for the next person to pick up from that and run with it. So, and sometimes this leads to the new person doing the work again from ABCD, so that's from the beginning. So project handover transition not done effectively. This I already talked about. Business not involved in the reviews of project progress, which I have talked about in the context of the business requirement. It is very important that business is involved in the reviews so that they understand whether the project is progressing in the right direction or not, whether the technical people have understood the problem right or not. So it is very important that the business people are involved in the business reviews. So Umesh, so you can take over from here.
Yes, thank you very much, Umesh. I think yes, I think in summary we discussed about what was the framework that is involved in executing a machine learning and AI project. Starting from requirements data. We talked about model science and deployment, both theory as well as we covered extensively. And then we have experience in executing many such projects. And in future, if you have any questions, you are free to contact us. Umesh at sigma-u2analytics.com or Umesh at mytechnospeak.com, and also refer our books where we have covered extensively with a lot of case studies. I have received a couple of questions from the audience, which I would like to take those questions before we end the session. One of the questions is, how do we select best algorithms? That's an excellent question. Basically, this question I come across very often. Which algorithm to choose, which supervised machine learning or unsupervised machine learning, how do we know which is the best algorithm? So the whole algorithm selection depends on the context of the problem that you are trying to solve, whether it is supervised or unsupervised. That is number one. Then if it is a supervised, whether you have a label data or not, so that is very important. Then accuracy of the result required, what is that you are expecting the results, the limitation of the algorithm. So the size of the data, the number of features that are there in your data. If you have 100 features and which algorithm to use, whether I should use a decision tree, whether I should use name-based, whether I use support vector machine. So all these things, depending on these primarily these four factors. So one is whether you have a label data or not. The second one is number of features that you have in the data. The third one is what is the size of the data? Is your size of the data, the samples that you have in the data, is it larger than the number of features that you have in the data? So that is very important. And is it what kind of distribution that you have? Is it a normal distribution, or if it is not a normal distribution, skewed distribution? So how do we handle all these things? So all these things have got an influence on the algorithms and which algorithm you have to use. So another important aspect is whether you have a categorical data, whether you have a numerical data, whether it is a combination of numerical data and categorical data and text data. So do you need encoding techniques to convert the text into numerical? So whether do you need normalization? So a lot of these things influence the kind of algorithms and the output of the algorithm. I hope I answered that question. So I have another question which I would like Umesh and I to answer. That is, when do we require a data scientist? Whether we need a data scientist or not. And this is something which we have come across very often. I would like Umesh and I to answer this question.
Umesh, thanks. This is the question we have listened many times from the people with whom we have worked on. So data scientists definitely add value to the projects, okay, and where so it is basically a problem has been already solved, and so typically available in the public domain, and the organization has got similar issue, and it is similar data, and it is straightforward to apply, then a data engineer is sufficient. But when the requirements are very complex, and the algorithms may have to be built some certain times from the scratch, or algorithms have to be modified in the context. In that case, okay, that is basically in the case of complex requirement, okay, and in the complex in the case of complex projects, okay, extensive data, it is always advisable to have the data scientist. But typically, a data scientist, as he or she is able to guide other people, data engineers effectively, I suggest every organization to have a good data scientist who can guide the people within the organization. Okay. So thanks everybody, and so thanks everybody for participating in session. So we are almost getting into 1 hour mode, and as Umesh mentioned, you can write to us if you have any questions at Umesh at sigma-u2analytics.com or Umesh at mytechnospeak.com. Okay, thanks for participating, and look forward to talking to you again. Thank you very much.
Thank you very much, and please provide your feedback. It will be very encouraging for us to do more talks. Thank you so much.